Welcome back, everybody, to lesson 3.1 about the law of sines. So the law of sines is going to be a thing that we can use to solve triangles. So let's get cooking, solving some triangles. So in the past, we used the Pythagorean theorem to solve for sides of right triangles, and we also use trig ratios to solve for angles in right triangles. So today we're going to learn a method to solve for sides and angles of any type of triangle, and this method is the law of sines. So what the law of sines says is that if I have a triangle, so if I have a triangle with angles A, B, C, and then I call their opposite sides respectively A, B, and C. So little a, little b, and little c are the side lengths, big A, big B, and big C are the angle lengths or angle measures. So for any triangle with these sides and these angles, this ratio holds true. What this says, there's a common ratio between the sine of an angle and the opposite side. So sine of A over A equals sine of B over B, which equals sine of C over C. So let's take a look at how we can use this to solve a triangle. So for side angle triangle. So first, one thing that I like to do is make sure that I draw myself a diagram so I have an idea of what this triangle that I'm working with looks like. Again, it's probably not to scale, but it'll give me an idea of what this thing looks like. So if I have an angle that's 40 degrees here, the opposite side A is 4. Let's say if angle B is here, this is 60 degrees. If angle A is 40 degrees and angle B is 60 degrees, then angle C would have to be 80 degrees because all the angles in a triangle add up to 180. So side B would be across from angle B. So we're going to end up finding side B. And then we're also going to find side C. All right, so let's say that I want to find side B. I can set up a ratio. This says sine of 60 over B is equal to, the one pair that I actually have is I have angle A and side A. So I'm going to set this equal to sine of 40, that's sine of A, over 4, because that's the side length for A. So now in order to solve for B, I'm going to do this slowly the first time. I'm going to show what we do. We cross multiply. Again, we can cross multiply when we have two fractions equal to each other. So I have B sine of 40 equals 4 times sine of 60. So then B would be equal to 4 sine of 60 over sine of 40. So now you're going to grab your handy dandy calculator, and before you do anything with your calculator, you want to press the mode button and check and make sure that you're in degrees. So most of you, your calculator is probably currently in radians because usually we work with radians. But if we're given angles in degrees, then I want to switch it to degree mode. So that when I take sine of these angles, I'm taking sine of a degree measure as opposed to a radian measure. So I'm going to quit out of this screen. Again, we need our calculators here because we know sine of 60 because 60 degrees is pi over 3 on the unit circle, but we don't know sine of 40. So we're going to use our calculators to help us find this answer. So this is 4 sine of 60. All right, so that's 4 sine of 60 divided by sine of 40. And that gives me about 5.4. So B would be approximately equal to 5.4. All right, so I'm going to do a similar strategy for C. So I have sine of 80 over C equals sine of 40 over 4. I could have used this value for B and 60 degrees here also. The reason I'm using sine of 40 over 4 is that these are exact numbers. These were the numbers that I was given. So these are exact answers. And just to try and get as accurate of an answer as possible, I'm going to use the exact numbers. That may not always be the case in some problems. You might have to use some approximated numbers, and that's okay. But I'm just trying to get as exact an answer as possible. All right, so then when I solve for C, all right, C will be 4 sine of 80 over sine of 40. All right, real quickly, I didn't address this in the last round, but let me show you real quick something that you should not do. So if you're following along with me, put down your pencils right now and do not ever do this. This is not 4 sine of 2. Remember, sine of 80 and sine of 40 are actual numbers. I can't divide 80 by 40 here because those are inputs to the trig function, so don't do that. If you do that, you have violated kind of the order of operations. You're supposed to take sine of 80 before you do anything else with it because that will output a number. All right, so I'm going to grab my calculator. I'm going to do 4 sine of 80, and then I'm going to divide that by sine of 40. I really should use parentheses to denote the numerator and denominator, but because multiplication, I mean, your calculator is going to go in the order you write it in. So it's going to multiply 4 by sine of 80 first, and then divide by sine of 40. And my answer is about 6.1. So C is approximately equal to 6.1. So up here on the triangle, I've got that B is approximately equal to 5.4, and that C is approximately equal to 6.1. So when you get to the end and you've got everything in your triangle solved, a quick thing that you should do before you move on is just make sure that your answers make sense logically for the problem. So for example, smallest angle should have the smallest side opposite of it. So 40 degrees is the smallest angle, 4 is my smallest side. That makes sense. 80 degrees is my largest angle, 6.1 is my largest side. They're opposite of each other. So logically, my answers make sense. That doesn't guarantee that my answers are correct, but logically they make sense. So we're good. What we've got logically makes sense. We're going to move on to another problem. So we're going to do this problem in class. So some more practice with law of sines here. But one thing that I did want to point out is if you ever have a side-side angle triangle, this is called the ambiguous case, because depending on what these side lengths in this angle are, there are 4 different possible outcomes here. Really three outcomes, but there's 3 outcomes. 2 of them are the same, but they look different when they come out. So one is that there's no triangle. Basically what's happening here is whatever these side lengths are, if I try to set this triangle up like this, A is kind of like a swinging pendulum. And if it's too short, if A is too short and I can't reach this line down here, then there's no triangle. If A is too long and it's swinging along here, so if A is too long and it's swinging along here, then I could hit here or I could hit here. So there would be 2 possibilities. So 2 different possible triangles that could happen. All right. The last possibility is there could be 1 triangle. All right. And that would happen 2 ways. One way would be if A is equal to whatever this height is right here, or the other way would be if A is greater than or equal to the length of B, then the only possibility would be I hit that bottom line somewhere way over here, and it would be too long to hit a second place on this line. So it would be 1 triangle with typically a large angle up here. All right, so we're going to look at an ambiguous case. And so fortunately, when this happens, or when we have this ambiguous case, when we have this ambiguous case, the law of sines will naturally lead us to the correct conclusion. All right, so we're going to take a look at one of these. We're going to solve this triangle, and we're going to see what ends up happening. All right, so first we're going to draw ourselves a picture of the triangle. Again, this is not necessarily drawn to scale. I just want to draw what's happening here. So I've got the angle C is 50 degrees. All right, I've got the angle. So here's angle A. I don't know angle A. I don't know angle B. And in this case, I can't figure those out. But I do know that angle C is 50 degrees and that side C is equal to 1. So let's try to find side A. So if we try to find side A, so we can set up a law of sines that says sine of 50 over 1 equals, oh, sorry, side A is 2. I'm sorry. So angle A is what we're finding. So sine of 50 over 1 equals sine of A over 2. All right, so now let's try to solve this for sine of A. So I end up with an expression that says sine of A equals 2 times sine of 50. All right, so the first thing that I want to do is I want to do 2 times sine of 50. 2 sine of 50. So 2 sine of 50 is approximately equal to 1.5. So sine of A is approximately equal to 1.5. So what I should notice here is that I run into a problem because the maximum value of sine is 1, which means there is no way for this angle A to exist. So if this angle A does not exist, then there is no triangle. It is not possible to create a triangle from this information. So there is no triangle. If you're unsure though, remember what I could do analytically, what I could do algebraically to solve for A is I could take the sine inverse of each side. Now I'll be left with A is equal to sine inverse of 1.5. And if you really want to try to do that with your calculator, here's what happens. If you do sine inverse of 1.5, your calculator says, uh-oh, error domain. What a domain error means is that you've entered something. And if I press go to, it'll show me where the error is. I've entered something that is not within the domain of sine inverse, which means that sine inverse of 1.5 does not exist. So there is no triangle. So here's what this would look like right here. So if I've got this side that's 50 degrees, this side A is equal to 2, and this side C is equal to 1. What's happening in this case is C is too short to actually swing down and hit this line at some point. If this angle had been smaller, then there would have been a possibility that C could actually hit this line. But because it's too short to actually reach that line, there is no possible triangle that I could draw that would fit this information. All right, so we're going to do some of these in class, a couple examples in class, the ambiguous case. So I wanted to throw this example on here too to show you that there are limitations to the law of sines. So if I were to draw this triangle where I have that side A is equal to 3, side B is equal to 5, side C is equal to 7. So if this is angle A, this is angle C, and this is angle B. If I were to try to solve this triangle right now using just the law of sines, let's say that I wanted to find angle C. I would have sine of C over 7 equals sine of A over 3. I am stuck. I'm limited because I don't know A or C, so I'm not going to be able to solve for either of those variables. And I'm going to end up with kind of the same problem. And if I could even add in sine of B over 5, I'm stuck because I don't know any of these angles. So what we're going to learn next time is a thing called the law of cosines that we can use to help us evaluate some of these angles in a side-side-side triangle. All right, so that is it for today. Today we talked about the law of sines and how to use the law of sines to solve triangles. I hope you took some good notes, and I hope you come to class ready to learn and share any questions that you have. And I will see you next time. Have a fantastic day.